So in this video, we're going to look at vertical transformations of the two base sinusoidal functions. So f of x is equal to sine x. We'll look at how do we transform that, and f of x is equal to cos of x. And you'll see we can put an a value out front. That's going to be a vertical transformation. We can add a c to the end. That'll be a vertical transformation as well. And then in our next video, we'll look at how k and d influence this as well. So first, what does the a actually do? Well, this is the same as what we learned in our transformations of functions unit. So a is a vertical stretch or compression. So it's going to do a vertical stretch. And that's in the case that if a is greater than 1. Or it can also do a vertical compression. And that's if a is in between 0 and 1. So it's some sort of a fraction, like a half or something like that. The other thing that a can do, if you remember back to our function transformations unit, a can do reflections. So it's going to be a reflection in the x-axis, so a vertical reflection, if a is negative. So those are the two different things that a can do, either vertical stretches and compressions or reflections. You'll remember there's actually a formula for amplitude for a sinusoidal function, and that's the maximum value minus the minimum all over 2. So a is half of the difference between the highest and the lowest point on your graph. All right, let's try an example of that. So here's a sine function. I've already graphed the sine function for you, so you kind of have that start. And here we're putting an amplitude of 3. So we're saying a is equal to 3. So what that means is that this function is going to be stretched out vertically by 3. So any points that were here at y values of 1, we're going to multiply that by 3. It'll go all the way up to a 3 here. And a y value of -1 will go down to -3. These places along the midline will stay in the same location. So our x-intercepts stay the same. What we'll get is this stretched out sinusoidal function that looks like this. This point here, how is it -1? It'll be multiplied by 3, so it goes down to 3. Point at +1 multiplied by 3 goes up to +3. Points along the midline stay put, and we get this here. So that is what 3 sine of x looks like. Here's two different functions. So I've graphed the red one is the base function of sine x, and we want to know what is the equation for that purple function there. Well, the first thing you can notice is that there's definitely a reflection going on here. I could kind of draw a middle step here, which is this function right here, this orange one, that would just be f of x equals negative sine of x. So that's just a perfect reflection in the x-axis, right? I've just reflected each point down, reflected those points up there. But notice the purple one's not quite a perfect reflection. It's a reflection, but then it's also stretched out. Instead of having going down to just -1 and up to +1, it goes down to -2 and up to +2. So you can see the amplitude has been stretched by a factor of 2. Or another way to think about it is if I do amplitude is y max minus y min over 2, the highest point here on the purple function is 2, the lowest point is -2, -2 minus 2 divided by 2 gives me 4 over 2, which is 2. So the amplitude of that purple function is 2, but it's also a reflection, so it's a -2. That means my equation for the purple function must be -2 sine of x. So that reflection in the x-axis is the negative and stretched out by 2. All right, let's look at the midline. So that's the c value. And c, if you remember from our transformations unit, this does the same thing here. It's a vertical slide. By c. And if c is positive, you slide up. If c is negative, you slide down. So positive c, slide up. And if you have a negative c, you slide down, which is pretty intuitive. There's actually a formula for c as well, though. So c is basically the average of the highest and the lowest point. So a midline is an average, right? It's in the middle. So we could take y max and add y min and divide by 2. And that would be an average of the highest and the lowest point. So that's the formula for that midline c. And I could draw it on this picture. That line right there is the midline through my purple function. And that is actually c. So that whatever the midline is tells you c. You can see that it is going through 3 here. That means that the midline on the red function here has been slid up by 3 units there, so c equals 3. So my formula for the purple function would be f of x is equal to, it's just a regular old sine function that we started with here, plus c, and c is 3. We've slid that thing up by 3. You can also check with your formula. C is equal to the max plus the min over 2. The highest point on the purple function is 4. The lowest point on the purple function is 2. Divide that by 2. That gives you 6 on the top over 2, which is 3. So that c value is 3. Our midline is 3. All right, let's put the two things together. So say you have negative 2 sine x plus 1. What you want to do when you're graphing these is start out by just graphing the basic function. So start out by graphing, in this case, it's a sine function. Sometimes it'll be a cos, but here it's a sine function. So you'll want to be pretty familiar with graphing a sine function. So it has x-intercepts at 0, 180, 360, max point at 90, and 1 min at 270, and then sort of the same idea over here. Kind of want to connect your dots. So we always start out by graphing that base function. This is a sine function. Sometimes you'll do base function of a cos. Then I usually go left to right. So I do the amplitude first. The amplitude is negative 2. So what you can do, if you want to do the, you can do both at once, both steps at once, or you could do it in 2 steps. You could graph this first. F of x is 2 sine x. So we could graph just that much. So just do an amplitude stretch of 2. That would bring the stretching up to 2, keeps your x-intercepts, your midline stays the same at this point. Just stretches out those highest and lowest points. So that would be f of x is 2 sine x. And then what you can do next is the reflection. So next you can do the negative 2 sine of x. So take the graph you just drew and reflect it in your x-axis. So this point that was at positive 2 goes down to negative 2. Points along the x-axis stay the same when you do a reflection. This point that's down here at negative 2 flips up to positive 2. Get this here. There we are. All right, the last thing we need to do is our plus 1 at the end. So the whole function is negative 2 sine of x plus 1. So that plus 1 means we take every point and slide it up by 1. So take this point here, slide it up by 1 point. Take this point, slide it up by 1. This point slides up 1, slides up 1. So this is changing where your middle line is for your function. Everything slides up 1. And it should look like this. So you'll notice on your final function, the middle line is no longer on the x-axis, it's slid up to 1 because c is the midline. All right, let's do one more example. So say you have a half cos of x minus 3. So the first thing you want to do is draw your base function, which is a cos of x. So y equals cos of x. And cos, if you remember, starts at 1, goes through 90 and 270, goes down to -1 at 180, up to 360. Make sure that you have cos and sine memorized. Don't be looking back at your notes for sure to draw cos and sine each time. That would just be really time consuming. All right, so there's our base function. F of x is cos of x. Next, I'm going to do the amplitude. The amplitude is half of that. So I'll graph this. F of x is half of cos x. So that means I'm going to compress this vertically by a half. So anything along the midline will stay the same. So these x-intercepts stay the same. But my max value is no longer 1, it's just going to be a half. My min value is no longer -1, it's going to be -1/2. And I just max out at a half here, half there, -1/2 there, and I get this sort of compressed, vertically compressed function. Looks like this. Then my last move is going to be that -3. So f of x is a half cos of x and then -3 at the end. So that means I need to take every point here and slide it down 3. So this point, instead of being at +1/2, it's going to go all the way down here to -2.5. Here this was at 0, it's going to go all the way down to -3. This point down to -3.5. This point down to -3. Here down to -2.5. Let's go down to -3. There we go, down to -3 as well, down to -2.5 here. And then you can connect your dots with that nice cos function. There we go. You should notice your midline is at -3. I'll just draw it on there. That's because C is the midline. And you're all done.